Another kind of extension is to add varying kinds of behaviors to a system. The decorator pattern was designed to do exactly this. What the decorator does is it allows us to add arbitrary combinations of behaviors to individual instances of objects, rather than adding them to every instance of a class. The way the decorator does this is it allows instances of an object to be wrapped with new behavioral responsibilities. This is nice because it means all possible combinations of behaviors do not need to be compiled in advance. The decorator pattern is a classic example of composition over inheritance. While the pattern does use inheritance internally, all of the power, or most of the power of the pattern, really comes from these encapsulated fields that are used through delegation. Here we have the canonical depiction of the decorator design pattern. Now the first thing you might notice looking at the structure of this pattern is it looks exactly like the composite pattern which you would have seen in a prior course. Just like strategy and state varied in their intent, the decorator and composite patterns also vary by their intents. So the intent of the decorator pattern is not to aggregate functions as we saw in the composite pattern. The intent of the decorator pattern is to be able to wrap new behaviors onto an instance of an object. The component interface declares the high-level actions that need to be performed on all class instances within the decorator pattern. So what you see here between the component and the concrete components is just normal inheritance, right? The concrete components are our objects within our class that need to perform the action that we care about. But we also want the ability to layer on new behaviors at runtime, and that's where the decorator comes in. Now the first thing to notice about the decorator is that it has this dependency back on component, and we can see that reflected also in the parameter wrap here. The parameter is of type component, and all of the subtypes of decorator also have the same action method associated with it. All decorated objects will have the same type as the concrete components. That is, they all implement the component interface. This is useful from a client's point of view because it means they don't need to be aware of what type of wrapping has taken place on top of the concrete components. Whether they have a concrete component or a concrete component that's been wrapped in a decorator 1 or a decorator 2, or both of them, they don't need to be aware of that distinction. Let's take a look at how we would go and use the decorator. So to instantiate a concrete component, you do exactly what you'd expect. You just say new concrete component. And when you call c.action, this action is going to be performed. But the magic in the decorator pattern happens when we start to wrap the object. So let's take a look at what that looks like. So first, we would go and just reassign C with the new wrapped type. And the way that we would do this is we would just create a new decorator and pass in the existing object into that constructor. So what we've done here is we've gone and enclosed the existing instance of concrete component within decorator 1. This is where the composition part of the decorator really starts to kick in. So when we call c.action, what ends up happening? Well, the first thing that happens is that decorator 1's action method here gets invoked and does whatever that action is going to do. And at the end of this method, what it's going to do is it's going to call this.wrap.action. And since we know that decorator 1 is wrapping a concrete component, what it will end up doing is going and calling this action method here. Now this allows us to provide multiple layers of decorators as well. If we wrapped this C in another decorator 1 and a decorator 2, it would go through all of those action methods successively by accessing the wrapped object through this wrap field. Let's take a look at a design problem within the Mario game that could be helped by using the decorator pattern. So here we have our game frame, and sometimes we might have behaviors that we want to layer in front of the view of the game frame to add a bit more visual appeal to the game. So here we have the lightning event. The lightning event is when there's a lightning action. It causes the screen to blink brightly. The POW event is when one of those POW blocks gets hit and the whole screen kind of shakes. And finally, there's this squid event, which happens in some Mario games, where a squid creature goes and splurts black ink on the screen so you can't actually see. Now, if you only had to deal with these three behaviors independently, it would be fine. But what about if we wanted to layer them on at the same time? What if there was a lightning, and while a lightning was happening, someone hit POW? Or if there was a POW was shaking the screen and someone invoked the squid at the same time? This would start to add to many, many more static types. So it would look something like this. Right? And each of these types would have to go and be implemented as well. So we have lightning POW, lightning squid, pow squid, oh, and of course we need, who can forget lightning pow squid? And we can quickly see how this adds a whole bunch more types to our system. So what the decorator is designed to do is it makes it so we can go and layer these independently without having to think about all of these different combinations. Now this only has 3 options. What if we had more, right? As soon as we add another potential decoratable object here, the number of classes we need is going to grow significantly. And it turns out in the game this actually happens, right? Because we don't just have a regular game frame, we have 3 types of game frames. There's the normal game frame, the underwater game frame, and the lava game frame. And so all of these different types would need to be encapsulated for those 3 different types of frames as well. And this would grow completely unmanageable extremely quickly. What would this look like at runtime? So here we have a game frame object instance, right? Someone's created a game frame. And we want to go and layer one of these behaviors on top of it without having to do this whole combinatorial explosion problem. Right, so on top of a game frame, we're just going to go and wrap it in a lightning. And this is what our object now looks like, right? We have a game frame, and it's encapsulated within a lightning. And if a lightning is currently flashing and someone hits a POW, we can encapsulate it again. And in this way, what we've done is we've gone and layered on new behaviors on top of the game frame without having to go and create all of these different independent subclasses. And to the game, whatever has the reference to the game frame in the first place, it has the same type as well, right? It is always going to be of type game frame. So let's draw out the whole pattern and see how it applies to this example. What we've done here is we've applied the decorator pattern to that previous design. So we can see that we have the frame decorator, which is with its 3 main concrete decorator objects, the lightning decorator, the POW decorator, and the squid decorator. And these are the 3 things that can be layered on top of the game frame. And we've gone and actually extended that design to allow for the normal level, underwater level, and lava level. So we can capture these decorators in all of these different kinds of levels. Now the thing to keep in mind here is that we can layer these arbitrarily. So again, we can have a lightning inside a POW, inside a squid, while we're in an underwater level. We can have that no problem. We don't have to add any new types. And these can be dynamically changed at runtime. So whatever client object has the reference to game frame can go and layer these new behaviors on dynamically. And that's a real strength of the pattern. Now it's important to keep in mind that the reason this works is all because of this one field here, this wrap field, because it is what allows the behaviors to be forwarded on to the encapsulated objects. Instantiating this pattern is exactly as we saw earlier with the canonical example. So here we have a game frame for the lava level, and the client, whatever has the reference to game frame here, has gone and said, hey, we're going to encapsulate the current game frame in a POW and a squid, and we can do these actually at the same time. And when we go and actually run this at runtime, we'll deal with the POW's render method, then the squid's render method, and then it will come back and run the lava's render method. Now one thing to note right here is that sometimes we might want to have a different behavior if we have multiple layerings of the same type. For instance, if there's a POW and another POW, maybe we want to shake the screen extra. And we can't actually do that within the decorator pattern because a decorated object shouldn't be aware of what kinds of sub-objects have been decorated within it. The same thing if we have an ordering problem. If there's any kind of implied ordering constraint within the wrapping, it's not actually going to work. Right? So we have to be careful about how we construct our objects if those kinds of properties matter to us. In summary, the decorator pattern provides a mechanism for us to layer behaviors onto an instance of an object. From the point of view of our solid design principles, the decorator pattern is particularly strong in terms of the single responsibility principle. In this example here, game frame is able to concentrate on rendering without worrying about things like lightning, POW, and squid. It leaves those behaviors to the subclasses over here. The decorator pattern also supports the open-closed principle. If we want to extend our system with a new behavior, all we need to do is implement the decorator type itself. And our existing concrete types will remain oblivious to these new behaviors that have been added. The decorator pattern is a well-understood example of using composition to extend your system. Now, there are a few things to be aware of. The first is that if your decorated behaviors end up being heavyweight, you might want to look at a strategy pattern instead of using a decorator. Also, some people find the decorator difficult for the same reason we might have seen in the state or strategy pattern, because you do end up with a proliferation of these small classes. Finally, debugging the decorator pattern can sometimes be tricky, because when you're looking at an object, it's hard to see all of the different layered objects inside of it. So the debugging process can be a little bit more finicky than if you just had a plain bare object.